Hey there, viewers, and welcome back to the South Main Auto Channel. That's a 2012 Ford Fiesta. It's from the used car guys. Been dropping them off this week, and this has the big 1.6 in it. Starts, runs, drives, everything is good to go. Got it sold, and the battery light is on, so indicating problem with the charging system. However, the vehicle seems to charge, and when we check it, it seems to charge just fine. It has a couple codes stored in it, indicating failure to communicate from the ECM to the alternator. So we're going to check that out, see what's wrong with it, see if it needs an alternator, see if there's a broken wire or what the problem is. These are the codes that are stored in it. We have the classic U12D006C, that's a classic code, loss of comm with generator control module, and then your U0469er 00-6 Charlie. Invalid data received from generator control module. And then something else here in the front control module. Yep, so those are like codes that are stored in it. So matches the criteria. Let's have a little look at how this thing works. So I just looked up theory and operation on it because we need to know how it works in order to test it. Fortunately for us, it's pretty simple because this is just a single wire alternator. So they've done away with, well, I haven't done away with PCM control, but the engine control module controls the alternator via data network, a LIN data bus, a local interconnected network. So it just has one wire going to it plus, your battery cable and stuff like that. Look up theory and operation on the alternator itself, and they write, the charging system supplies voltage to the battery and the vehicle electronic systems through the B+ cable. So it's going to be the big cable coming off the alternator. The PCM monitors the generator output through a dedicated local interconnect network, a LIN communication circuit. That's what they call it, LIN. The generator uses this LIN circuit to communicate the desired voltage set point from the PCM to the voltage regulator. So basically the alternator and the PCM, they talk to each other and tell each other what's going on, and the ECM says, hey, we need 15 volts. And beep, 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 sends little data packets down the line, and the alternator puts out 15 volts, or vice versa. The generator also uses this LIN circuit to communicate the generator load and error conditions to the PCM. So it can talk back to it and say, hey, I'm not doing happy. We're not good. Something's bad here. So at this point, it makes it super simple to check. We're going to use our AES Wave U scope. You don't need anything super fancy. I already got her sitting out over there so we can hook it up. I believe a LIN data bus works 0 to 12 volts. So we're just going to get these little square waves saying, hey, I'm talking. We're not going to know what it's saying or if the signal's corrupt or anything like that. We have codes stating that the PCM can't talk to it. So we're just going to make sure, do we have connection from the PCM to the alternator? If we do, we're going to assume the alternator is junk. We'll do a couple quick checks on the alternator, some quick voltage drop checks, make sure it's not a ground or a power supply issue to it, which I don't believe it is because the car still runs and charges. So a couple quick checks and then we'll pull the trigger. This thing is a son of a mother lover to get down to this connector. I was able to reach through the intake. Let's get this thing turned on. We're just going to use our little AES Wave U scope. We've used this in a lot of videos, and it's good for little quick checks like this. I was able to use pick, sit over here. If you have to unplug the alternator, I was able to come through the intake manifold this way, hit the release tab, give it a classic reach around, and get it unplugged. And I've got the connector, just a single wire. I think it looked like it was purple when I was fiddling to get it unhooked there. I get it twisted around so we can see it. I can just barely see the end of it here by the dipstick. And it looks like, now that it matters, what color is that? Appears to be purple. So what I wanted to do, because I wanted to back probe it while it was plugged in, but I couldn't. I tried and it didn't work. So I'm going to hook our scope to battery negative. It's a little crusty up there. We'll make sure our scope works, and it does. And then we're going to gingerly front probe, very gingerly. We'll just touch it on there, and it must be that left key on. Let's see, yes, we are at about 12 volts, and it looks like we've got some data packets coming across there. Let's change our time basis here. And there we go, folks. So it looks like our data bus line from the PCM to the alternator is intact. We'll get a little more time on the screen here. We can see it trying to talk. It's saying, hey, where you at, fool? And alternator is saying, hey, I'm right here, but I'm not happy. So that's pretty interesting. The LIN data bus is intact. So that's good. That means we don't have to do any short to power, short to ground, open circuit tests, nothing like that. If you're looking in the factory service manual, that's what's going to have you do. Unhook the PCM, short to power, short to ground, open circuit. We just went right to the alternator. The thing that I want to know is it should be charging. I'm going to grab just a regular multimeter. We're going to check, make sure it's charging. I'm assuming it is. It must have a default strategy. Perhaps if it loses communication, it must be able to default to a charging status, I assume. Get my battery in this thing. We'll get this baby fired up. We'll check and see. Now, a lot of your older Fords with the smart charge system, they would default at 13.7 volts. That was their default strategy, the old Gen Mon, Gen Com systems. If they didn't have input from the PCM, you'd start the car up, rev the alternator up till it hit about 1500 RPMs pulley speed, and you were good to go. So we'll go volts DC here. We'll see what our battery's at. I say it has to be charging because he drove it here and he drives quite a ways. Let's see. We'll go 20 volts. We're at 11.5, so theoretically we're fully discharged. Let's go ahead and fire it up. He's off and running. 1600 cc's of thunder. And you can see here it is charging at 14.28 volts. Maybe that's its default charging system voltage. I don't know, but we can do some quick checks where we have this hooked up. We can do some voltage drop checks, make sure everything's good at the alternator, and then pull the trigger. Seems kind of silly to be putting an alternator on it just because the battery light's on, but all right. So we'll do a voltage drop from negative to alternator case. Get that clamped on there. We should be very low. And if the alternator's not charging, we wouldn't be able to do this, but because it is charging, we can do this. And we have about 30 millivolts of voltage drop with the alternator loaded, so that's good on the ground side. I'm happy with that. Now we can voltage drop the positive side. We'll just move our lead here. We'll go from positive to positive. I'm going to have to remove the rubber without touching anything. It's like playing Operation. The rubber cap is off and appears to be falling on the ground somewhere. Behind me? Oh, there it is. There's the little rubber donger. We took that off. Now we'll see if we get our hands back down in here. We're on battery positive post, and again we've got about 34 millivolts, so not a big deal. Everybody looks happy. So what's that mean? If we come here, we go at 20 volts. We're 14.34, 14.33 at the alternator, so technically if we switch that up here, we should be about 14.30 would be my guess. If our math is correct. Survey says 14.30. So there's a little bit of voltage loss. Oops, shitty connection. 14.30, a little bit of voltage loss through connections, through wire size, but completely acceptable. The car needs an alternator. Simple as that. Hopefully that made sense to you. A couple quick checks. Like I say, voltage drop, positive side, ground side, and that can only be done if the alternator is working, because without current flow, there is no voltage drop. The test would have came back perfect. It's perfectly acceptable to have some voltage drop. I'm sure there's a general rule what's too much, you know, maybe a half a volt. I don't know. You'd have to look to see what that is. Perfectly acceptable. We have LIN communication there. Whether or not the communication is corrupt, I don't know. But we have it there. If we didn't, we would have to go back to the PCM to say, hey, you know, PCM pooched, or is that, you know, broken wire? So I'm gonna get us an alternator coming. We'll unhook the battery, we'll swap it out, we'll see if our codes go away, and more importantly, see if our battery light that's on the dash permanently goes out. But I guess it's good to know that the alternator has a default charging strategy built in case there is failure to communicate. And through the miracle of modern television, the alternator's been replaced. We used a quality Power Premium Plus unboxed power from Napper. Approved made to OE designs, 100% new replacement components, and every unit is tested. And they put the warranty on the box. So we'll send this one back for a quarter. Put a warranty on the box, makes a man feel good. I'm gonna have to learn that whole skit because someday I'm gonna have to use it. We all know you can get a nice looking steak from sticking your head up. Got some scan data pulled up here for us so we can see desired versus actual voltage. So it wants it at 14.32 and we can see we're holding pretty good around 14.32. And we'll check for trouble codes. Had the battery unhooked there when we did the process. Really easy alternator to change, just 3 bolts, stretch fit belt. So roll it up and roll it on, or put a new one on, whichever, if it's not the used car guy. No fault codes detected. And let me look on the inside, make sure the battery light's not on. Hopefully not, because that's what we came here to fix. We have no battery light on. Fantastic. Just like Back to the Future. We're going to 7/26/2011. If we can get up to 87 miles per hour. Must not have hit the maximum speed to go back to 2011. And I don't even remember if that was a good year. It's got to be better than 2020 though, do we all agree? Can I get an amen? At any rate, that's how you check the alternator on your Ford Fiesta or Festiva, or whatever this car is with the big 1.6. Simple system. Just your classic LIN bus controlled alternator. And I've seen a lot of alternators on newer cars with these smart charging systems and stuff are like that, where you just have your power, your ground, and then your LIN bus. No more, external regulators, anything like that. They're still regulated by the PCM, but through, jibber jabber back and forth, more so than controlling the actual regulator, if that makes sense. Probably doesn't. So hopefully you guys understood that. Easy enough to check. Do we have a short? So that's going to include short to power, short to ground, short to another circuit. Do we have an open circuit or high resistance? Those are the 3 things that could have acted up on that wire besides, corrupt data, perhaps, corrupt messages being sent. But I've never seen that, so not to say it can't happen. But anyhow, what should happen is you should happen to go down to that comment section, leave a question, comment, criticism, concern, way down there, subscribe, ring the bell, of course. Find us on our socials, the Facebook, the Insta, the YouTube. Just remember, viewers, if I can do it, you can do it. Thanks for watching.